Okay, I'm going to go through all the open response questions using my data from my USA infection fatality rate chart. If you don't need help with all of them, you can fast forward and just go to the ones that you need help with. Otherwise, if you can watch this while you're answering yours, it's completely up to you. But hopefully, this will answer any questions that you have about them. So on the first one, is the association between cases of infection and deaths positive or negative? I'm going to go back to my chart, okay, and look and see if my line is positive or is it negative? Does it go up or down? I'm not going to give you the answer to that one because that one's very easy. Two, what is the equation of the line of best fit for your deaths versus cases of infection chart? Remember what I said in the last video? The equation is actually right up here. You just have to rewrite it. You can take out the star and you need to add the y equal to your equation. So my equation will be y equals 0.0595x plus negative 1,736. Okay? Using the equation for the line of best fit, how many deaths does it predict from COVID-19 when there are 100,000 cases? Okay? Show all of your steps to solve the problem and answer the question with a full sentence at the end. Um, so if I'm looking at cases, I have two variables up here. We have the y and the x, and we need to know what those are. So the y-axis, if I look back at my chart, my y-axis is deaths. So my y is deaths. And my x-axis, looking at my chart, is cases of infection. So that's what the variables stand for. Y is death, X is cases of infection. Okay? So when I'm looking at this, they want us to predict the deaths when there's 100,000 cases. So cases is going to be X. So that's the first thing that you have to identify in order to be able to do this one is that X is equal to 100,000. One too many zeros. Okay? And now I can use my equation to find out how many deaths there will be for that amount. Okay, so I'm just going to substitute in for my y equals 0.0595 times my 100,000. Oh, mess this up here. Let me fix this. Okay, so I put my 100,000 in for x plus negative 1,736. Right? At this point, you need a calculator to calculate yours. But when I multiply those two together, I get 5,950. Okay, and then 5,950 plus negative 1,736 is 4,214. Okay, so my y equals 4,214. And if you look back up, we just said y is deaths. So that's going to be 4,214 deaths. So now I need to answer my question. Okay, how many deaths does it predict? So it predicts 4,214 deaths or 100,000 cases of infection with COVID-19. Okay, which is a lot of deaths. But for four, use the equation for the line of best fit. How many cases of COVID-19 are predicted when the deaths reach 500? So now we're talking about deaths. So Y is deaths. and we have y equal to 500. I'm going to use the equation again, but this time I'm going to put that number in for y instead of x. Okay, so I'm going to take out my y and put in 500. And I'm going to leave some spaces because I'm going to show my work right in my document. You can do it on paper if that's easier for you first and then transfer it here. All right, so if I need to solve for x, the first thing I need to do is get rid of this. So how do I get rid of negative 1,736? I'm going to add it to the left. I also have to add it over on the right. All right. I need to know what they're going to equal, so I just usually highlight and click underline to put an equal sign there. And then 500 plus 1,736 is 2,236. And that equals 0.0595x. My next step is, since it's this multiplication, I have to divide by that number. I'm going to use the underline again to show division. So I'm going to divide that and that by 0.0595, both sides of my equation. And then when I do that division, I end up with x equals, my number is pretty large. Yours is going to be different than mine. You'll probably end up with some sort of decimal. Now, in this case, we found x. So that's cases of infection. So I have to answer my question with a full sentence. And I also want to round my answer because it doesn't make sense to have a decimal. So I got to round up the 9 up, which makes that last piece, the 79, turn into 80. Okay, so there will be 37,580 cases of infection. Sorry, I can't seem to type. Cases of infection by COVID-19 when there are 500 deaths. So don't forget your full sentence, okay? You'll get a point for writing that sentence out and 2 points for your work. All right, number 5, what is the average rate of change slope from the equation of the line? You don't have to write your equation again, but I'm going to put mine here so that I can make sure that you understand where I'm getting this from. And what you have to remember is y equals mx plus b, okay? And don't forget, m is equal to slope, b is equal to y-intercept, okay? So in this case, we're asking for what is the slope? I'm looking for slope, which is m. If I remember from y equals mx plus b, that's in front of the x. So go to your equation. That is the number in front of the x. So my average rate of change, or my slope, is 0.0595. Okay, and that's from the equation. Now the next thing we're going to do is we are going to find the slope using 2 points. So you're going to pick 2 points from your data, from your spreadsheet in columns B and C, and you don't want them to be next to each other. And you cannot pick 0 because we have too many zeros in our table. So you have to pick something that has a death of 1 or greater. So we're going to pick the points, and then we're going to find the average rate of change between those 2 points. Okay, list the points that you used and show your work. So I'm going to look at my table. And you're going to notice in my table, I have a ton of zeros if I go scrolling down. 0, 0, 0, 0. My first case that is in a 0 is right here. So 70 and 1. So my x is 70, my y is 1. I can use that point. And then I don't want you to pick the one right next to it in the table. Go a few down. You have tons of data, so you can pick any point. I'm going to go and let's pick this one, 311 and 15. So those will be our 2 points that we're going to use. So the first thing that I need to do is put my points, 70 and 1 and 311 and 15. I picked my points. Now I need to find the average rate of change. Okay, so how do I find the average rate of change? Well, I find the slope. And I just put the slope formula right here, y2 minus y1 over x2 minus x1. So remember, if 70 is x1 and 1 is y1 and 311 is x2, 15 is y2, I'm going to take those numbers and substitute them in for average rate of change. So what I end up doing is slope is equal to, I'm going to subtract my y's, so 15 minus 1. I accidentally clicked in the wrong spot. Okay, so I'm going to do 15 minus 1. And then I need to divide that. I'm going to use the underline by the subtraction of my x's, which is 311 minus 15. Okay, actually not 15, it's 311 minus 70. I need to divide those two, and that will tell me my slope. And you can fix your format a little bit if you put spaces in. Depends what you want to do. That's going to equal 15 minus 1 is 14. Okay. And then 311 minus 70, which is 241. 14 divided by 241. I've got to do that on my calculator. And for this case, it is going to equal 0.05809. So that's the slope that I found from my 2 points, and I showed all my work. Your slope's going to be different because you're going to have different points, okay? But it may be close to your other slope, it may not, and that's what we're going to do next is compare to the slope from the equation. So how does the average rate of change from the equation compare to the average rate of change that you found above? My equation for number 5 is this, 0.0595, okay? And so I need to take that number, and compare it to the 0.05809, okay? And when I'm looking at them, so what's different about them? Well, they're pretty close, and yours may not be nearly as close as mine. It will depend. But I noticed that the equation one is just slightly higher than the one I found in number 6. So the slope of the equation close to the slope of 0.05809, but 0.05809 0.95 is slightly higher. Okay, so I made a comparison between them. And this could just be the points that you pick. It is going to be different. Remember, it's finding the slope of the line, whereas you actually found the slope between 2 points. So they're not going to be exactly the same. So let's look at 8. Give an interpretation of the average rate of change slope of the function in the context of the problem. Use the average rate of change from the line of best fit. So now we're going to look at what does this actually mean, that 0.0595. So let's talk about what that means. Okay, so I had to pause so I could go get this equation here. Remember that the slope, while we use this y2 minus y1, it also means the change in y over the change in x. So let's look at what that is. Well, our y-axis is deaths, okay? So we're talking about the change in the deaths over the change in x's cases of infection. So that's what our slope means to us, okay? The change in the deaths over the changes of infection, all right? So when I look at a slope like 0.0595, we're talking about the deaths per case of infection, okay? So 0.0595 deaths for every one case of infection. Right? And this doesn't make a whole lot of sense right now. It's hard to visualize. So that's why we're going to do the next step, which is converting this to a percent. All right. So we're going to convert the average rate of change to a percent. And once we get the percent, we are going to explain what the percent means using what we talked about earlier. Okay, I had to get my computer charger. So as I said, let's convert that to a percent. And we change things to a percent by multiplying by 100. So if I do 0.0595 times 100, I'm going to get 5.95%. Okay, so I changed this to a percent. Now, what does that mean? Okay, well, we talked about this in the introduction video, that means 5.9% cases of infection result in death, right? But what does that 5.95% mean? Well, remember, 5.95 is out of 100. So for every 100 cases, 5.95 people die. For every 100 cases of infection, all right? And we could even round that up to 6. So 6 people out of 100 end up dying, which is high. That's a lot of people when you think about what 100 people is. I mean, that's like, think about 100 people in a room and 6 of them are going to die. So when I go on to the next question, when you read the article, they had mentioned that they believe the infection fatality rate is 0.5% to 1% infection fatality rate. And they also mentioned, though, that the data is showing about 5%, which is pretty close to the one that I got. So why would our percent 9 be higher or lower than that 0.5 to 1% infection? And we talked about this, and I'm not going to type this answer out because I'd like you to write this in your own words. But we talked about what this means at the beginning. Okay. Um, all right, listen there. And I want you to write it in your own words. When you find the infection fatality rate from the data, remember the only people who are being recorded are the people that are tested and they are positive. So that means they actually have to be tested. Well, if you think about New York State and really all of the US, the only way people were being tested in the beginning was if they were severely sick and they were hospitalized, or if they were exposed to somebody else that was severely sick and hospitalized. Okay. So our data, the data we have in the table, is the percent of people who are very, very, very sick. Okay. So it really means 5.9 of the severely sick people will die. Or let's say of the hospitalized people out of 100 will die, okay, of COVID-19. But that's not really the infection fatality rate, and we actually don't know what it is yet because they don't have enough data. They're saying they think it's zero point 0.5 to 1. Well, why is that? Because they're missing, and the data is missing, the people that are mildly sick or the people that are asymptomatic. Okay. So we have um, the article that you read talked about the antibody testing and how the country is trying to get these antibody tests done so they can have some idea how many people have actually been infected. Because the antibody test will tell you not only the severely sick that were hospitalized, but also the people with mild infections and asymptomatic infections. If we can tell how many people actually had the virus, then we can find out what the infection fatality rate actually is because we'll know how many people die. That's not going to change because you get death certificates and that number that is recorded in our table in this column, that's not going to change. But this will once they have an antibody test. Okay. So, in your own words, write this in your response to this question. 11. What is the y-intercept of the function from the equation? So, once again, we're going to use our equation. So, 0. Okay. And we also need to remember y equals mx plus b. Well, what is the y-intercept? Remember, y-intercept is b. Okay. So, what is in place of the b in our equation? So, for my equation that we're using together, it is negative 1,736. So, for this data, the y-intercept is negative 1,736. Okay. Now it says, give an interpretation of the y-intercept in the context of the problem. Clearly explain your interpretation. So if I look at my y-intercept, the point is actually 0, comma, negative 1,736. Because don't forget, the y-intercept is where it crosses the x-axis. Okay. And with that, what does that mean? Well, when this is saying when there are 0 deaths, there are negative 1,736. Or when there are 0 cases of infection, there are negative 1,736 deaths. So this is literal. When there are 0 cases of infection, there are negative 1,736 deaths. Okay, that's the literal answer. But here's my question. Does this make sense? Because to me, that doesn't make much sense. How can we have negative deaths? I mean, in actuality, if we have 0 cases of infection, we would have 0 deaths. Well, what you have to remember from your chart is that when the chart was created, the line is drawn through the average. Okay. And from mine, especially, there are a lot of zeros. So it's going to go in between all those zeros. And when it goes in between those average zeros, it's going to end up falling below, okay, the x-axis and go in the negatives on the y. So for my case especially, since I have so many zeros, it's falling pretty low on the y-axis at negative 1,736. Yours will probably be a lower number because you're not going to have as many zeros because your data isn't actually going to be as far back. So there are actually 0 deaths and there are 0 cases of infection. The line of best fit has to fall below the axis, be the average of all the data to the deaths. Okay? And you can write this in your own words. It also depends what your number is, if it is negative or positive. If it was positive, if, for example, my y-intercept was 0, comma 2, okay, then it would say if there were 0 cases, there would be 2 deaths. And that doesn't really make a whole lot of sense either. So unless you're getting 0, 0 as your y-intercept, the reason why that your y-intercept looks weird is because of the fact that you have you're drawing the average line. Okay, so let's go to 13. How would you rate the strength of the linear fit to the data? Weak, moderate, strong. If you need help with this, look at the Unit 6 Lesson 9 notes. We talked about the strength of the linear fit when you did those notes and those homework problems. I have to look at my chart. If I look at my line, my points are really, really close to my line. Okay, so my line is really strong. It's a strong line. If your points are around the line, but not very close, they could be moderate. They could be weak if they're really far from the line. So you have to look at your data and decide. Like I said, for mine, how would I rate? Mine is strong. Okay. And then based on the fit of the model, depending what your answer is here, how well do you think your model will predict the number of deaths based on the number of cases? Since I have such a strong line, my model is going to be a very good prediction. Very strong prediction. Number of deaths. Because my best bet is very close. All right. And that means, and what that means to you, that's our last question, by the way. But why do we even create these scatter plots? It's so that you can make predictions about things. Okay. So if I have an equation and, right, I have an equation, all right, I can find out anything. So say, for example, I'd like to predict like, uh, when does, when the number of cases, say when the number of cases or X is equal to 1 million. How many deaths do I have? So I can take my X, plug it into my equation, and I'll find out exactly or close to, not exactly, but close to the prediction of the number of deaths. Okay. Which is what you see going on in the news when they talk about making the predictions and seeing where the hospitals stand. Okay. The other thing too is if I want to know, let's say I want to know how about when will deaths reach 100,000? Okay. Then I would take that 100,000, plug that in for Y, and solve for X. So I would find out using my equation, I would find out the number of cases of infection when there are 100,000 deaths. What's cool about that is I can go back and make another graph with my dates and using what I just found out, the number of cases, then I can also make a prediction about what date would I have 100,000 deaths. Okay, so what I really wanted to do to see from this is yes, you can use real world data, and this is what they use to make all their predictions. Ours is a linear model. Okay, a lot of the ones that they're using are not linear models. They could be quadratics or exponentials. Exponential is what you see for the rate of infection, and you'll learn about that in algebra. Some of them are way more complicated than that, and you would need calculus to figure them out. But this is how you see them predicting what they want the country to do when you're allowed to reopen, based on when they say statistics. They're using things like this and they're using the graphs. Okay, so like I said before, make sure in the first video, make sure you turn in the open response questions. Also, make sure that you turn in your chart and your data. So you should have two things when you turn them in. They're due June 12th, which is Friday. The last absolute day I'll take them is Sunday because after that we have to do grades and it'll be summertime. It'll be the end of the year. Okay? So I really hope that you have a nice summer. If I don't run into you this summer, hopefully at some point next year I'll see you or you can stop in. If you have any questions about this project or anything else, feel free to email me. We can do Google Meets. I can even call you. And if you do need anything, even after school's out, you can email me. Okay? Have a great summer.